Hi everyone, I'm just going to do a little quick sound check to make sure everyone can hear me okay. Seems like it's pretty good. Looks like we're all good. I think firstly, just a big apologies for the slow start here today. We had some access issues with YouTube, which really slowed us down. But we got it all sorted and we're here now, so we're going to get stuck into it pretty quickly. Now, this lecture today is really all just about iteration 3. Well, not just about that. We're going to talk a little bit about Auth, which is kind of its own separate lecture, but we're going to be starting off with iteration 3 at the least. The purpose of the iteration 3 lecture is really just to talk through iteration 3 and see what kinds of questions that you have, if any. Obviously, the spec is pretty extensively written, so I'm not going to go and describe every detail for you. But I'm going to try and help explain some parts of it. And if you do have questions, it would be worthwhile asking. Now, I think it's important to remember that I had a very significant hand in the writing of the spec originally over a year ago. However, things have changed since then, and I haven't always been part of those changes. So the reason that I'm delivering this one is just because I have a fair bit of experience, but I won't know everything. I think that's really important because at the end of the day, you need to consult the spec or the course forum or something else, because I don't myself personally run this and make decisions on it this term. However, I am pretty familiar with it. So hopefully we can, provide some help there. Now let's just jump straight down to iteration 3. So here's the coolest thing about iteration 3, as you probably already noticed. It's really similar to iteration 2. I like to talk about iteration 3 as like it's the hardest iteration, but the jump from iteration 2 to 3 is less than the jump from iteration 1 to 2. There's definitely a workload increase because there's more stuff and we expect that you know more by this point. But the consolation there is that there's not as many new concepts that are introduced to you, right? Like iteration 2 is pretty big in terms of like, oh, well, we got to do, what would you call it? We got to do like TypeScript and we got to do linting and we got to learn about servers and all of that. That's not really the case with iteration 3. And in fact, that's all pretty evident just by having a look at the Swagger docs. You'll see the Swagger docs are pretty similar. There's just more stuff. We can kind of get rid of the iteration 2 docs, and now you'll see that there's actually just 2 new sets of new routes here. Now, the iteration 3 modified routes are the easier routes. There's actually less to do with those, just because they are like, you can basically reuse that from iteration 2 and just make some small changes to it. You don't need to do anything crazy. Whereas these iteration 3 routes are quite new and you will need to do more work for them overall. So most of the work will end up being there. There are some slight changes to behavior in iteration 2 to 3, which is kind of also well documented in the spec. So you can go read that if you'd like to. But if we look at the task for iteration 3, it's also, again, pretty similar. Make adjustments to your code based on feedback, implement new routes, work on project management and Git usage, and document the planning of new features. Now, if I always like to do this. You've probably seen this from iteration 2. I like to keep little notes in these lectures so that we can come back to things. If we just have a look at this one here, implement and test the Express server. It's auto-marked. The data's persistent, ESLint, good coverage. Okay, good coverage. So I'll say section 2, we have to think about coverage, structures, front end, comply with stuff, user sessions and passwords. So then we've got this part here, which is auth, to do with user sessions and passwords. If we look at the demonstrating effective project management and Git usage, that's all pretty much the same. However, there is a new section here, section 4, called document the planning of new features and planning. All right, so then we run through the rest of it. Running the server is the same as iteration 2. Implementing and testing features is the same as iteration 2. Test coverage, that is a section we're going to come back to because that's a new thing, quote unquote. This section here, planning for the next problem to solve, that is a new thing as well. Yep, sounds good. Now, one interesting thing about iteration 3 is that it's a more complicated, I guess, implementation than iteration 2. Because if you think about it, iteration 2 was predominantly focused with being able to basically sign people up, like admins up, to be able to create quizzes and to be able to do stuff with those quizzes in terms of, questions and whatnot. However, iteration 3 is all about the running of the game. So it's useful to think of iteration 2 as like the building of a quiz. Iteration 3 is about the running of a quiz. And in particular, there's two main chunks of new routes that you'll see. One is about managing a session because, you can basically like think of a quiz like a template. You can go and start a new quiz game. You might be able to run multiple games at the same time. Imagine you make a quiz for a bunch of year 12 students and there's 6 year 12 classes. Well, you might want all 6 classes to play their own game in their own class. So you can go and create a session for those. These are all those routes to do with managing sessions, getting the results of those sessions. And then the routes at the bottom are all about the students playing the game, because so far, every route we've been dealing with has really been about that admin, that teacher, that staff member who's modifying and manipulating the game. Whereas this is all about the people playing it. So if you're just a student, you want to join a particular session. You would like to get information about a session. You'd like to be able to submit an answer to a question in your current session, right? It's all kind of laid out there, as well as being able to kind of chat between students as well. So lots and lots of little bits of work there. But the important thing is that in iteration 3, as part of managing the session, right? Like if you create an instance of a quiz that you're going to play with your class, you want to be able to I guess move it along. Now you should know this because you played the actual Kahoot. But basically, like at any given point, you should be able to start the quiz, go to the next question, view the results, go to the next question, start the countdown. Like there's a lot of different steps there. In this part of the spec 5.6, it links you to just a drawing that we have, which shows you how there's different states in your program and how you're able to move between those states. So essentially, you're in the lobby. If you're in the lobby and you send the next question action, you should end up in the question countdown state. And then in the question countdown state, you wait 3 seconds to question open, wait for the duration to end, question close. Like it's all quite written out here. And yeah, there's a question in the chat. When I start a session, what should it be? In lobby. Yeah, I'm not sure if that's written in the spec explicitly, but it is pretty intuitive nonetheless that you do start in the lobby. I don't think you need to clarify that on the forum. I think that's pretty fine. I wouldn't stress too much. But we have this ability to, essentially update a session as an admin or get the session state, etc. That's all 5.6 is about. It's just like these are the different states of the game, and these are the actions that an admin can trigger to move between those states. Section 5.7 is also a new thing. We will come back to that. It's to do with how we want you to handle errors in iteration 3. This section 5.8 here, that's the auth part. We're also going to come back to that, right? We're just kind of highlighting the key areas we need to talk about. We have this section 5.9 on deployment. So one thing that we'd like you to do is we'd like you to deploy your application up to the cloud for iteration 3. There is a Labo 9 deploy on this that takes you through the details. We already did a deployment lecture that covered kind of the conceptual, academic, theoretical thinking around deployment, but we don't explicitly then have anything like in a lecture sense for you to do beyond that lecture. However, the way that Lab 9 deploys setup and everything else is such that there's really clear, solid guidance of how to go do that. Video walkthroughs, lots of instructions. So deployment is left to you to do in your own time at your own pace. And should be fine and dandy. Now, the next two parts here, 5.10 and 5.11, which is scoring and ranking in CSV format. So these two things are not really new concepts or new criteria. They are simply explaining, similar to section 5.6, more about how the game works. Now, just for clarity here, because I was involved in pretty much writing these a while ago, a long time ago now, the only reason these are in the spec is because we looked at putting this information in the Swagger docs, but we felt Swagger's just not really like a great documentation tool. So for instance, scoring and ranking, it basically says how to score people. So like, yeah, we could go and say, have this route here where we describe the results here and then try and write it in all this text. But it's just a bit cramped, and it's always possible people miss stuff. So instead, we just wrote it in the spec and basically said, look, if you look at the Swagger docs, it says lots of things like, percent correct, player correct, or if you go down to these results ones, it'll be like score, and how to rank that. Well, yeah, ranked by score, of course. And essentially just like, how do you determine what their score is? That's all that section's about. Again, I don't need to kind of paraphrase it because you can just go and read it, but naturally there is a calculation of the score that is part of it. Similarly, 5.11 CSV format, similar kind of thing. There's another route that you'll see in iteration 3 where you can get the results as CSV. It should return a URL that you can give someone, and when they load that URL, it gives them the CSV contents. And it should look like this, where essentially it's a column for player, a column for question 1 score, a column for question 1 rank, column for question 2 score, question 2 rank, etc., etc., etc. So you need to generate that CSV, store it in a file according to that format, and then that route returns a URL to that as well. That one's a little bit of a fun one. William's got a question in the chat. Just a question for starting a session. What does the passed in value of auto start num do? So auto start num, if we look at the starting of a session, what it does is it basically is how many you can usually, let me just check if it's written here, model. Yeah, number of people to auto start the quiz once that number of people join. If this number is 0, then no auto start will occur. Essentially, it's like, let's imagine that you only want 5 people in your quiz max, and once you get 5, you're like, I'm going to start. That's all it is. This is a good example. It's actually written in the Swagger docs. So William's question is clearly written somewhere. However, I wanted to maybe use this as an example for why we have some of this stuff in the spec, because the fact that William is asking this kind of shows that some of these things aren't intuitive to spot quickly either. So, it is hard to find. I acknowledge that, which is why we don't love it necessarily. And then we have final presentations. I'm not involved with that in much detail. I believe Yu Chao has kind of communicated that to you across the course, is my understanding. If not posted on the forum, but there is a final presentation for iteration 3. It's a 10-minute Q&A session, and you go and turn up and essentially present to it. It's been changed very slightly throughout the term, so hold out for the comms about that. Though the spec's pretty clear, I don't really have a lot more to add to that one. I think when we get into the marking criteria, it's pretty similar to previous iterations. The auto marking being 60% is a step up in terms of auto marking. This requirements are designed for future work. That's related to this part here. This document planning for new features. Code quality is still important, but because we feel like you should be getting it by this point, it's only 5%. Git project, same thing. It's still important, but because we think you're kind of figuring it out, it's only 10%. Feature demonstration. So we essentially carve out 10% of marks for your backend working with the front end and the deployment of your project to a public web server. So both of those are worth 5% each. And then our last 5% is for TypeScript. It's really important to understand that you need to add this rule to the linter to pass the TypeScript checks. But basically, you need to run npm run tsc get no errors, and you need to add this to your eslint.rc file. And I don't think it's really explained very clearly here, but let me just make that explicit for you. Yeah, you need to add this rule to your eslint.rc.json. So there's a bunch of rules. You just need to go and add that to your rules as well. I think the only reason we don't include that is just because, like, if you don't include it, you can still get full marks on linting. It's just once you include that, the linter now checks TypeScripty things as well. So basically only put that in if you're trying to get those 5% marks. If you're not trying to get the 5% marks, leave it out. If you are, you'd need to include it. Otherwise, you'll get nothing for it. So that's really important to understand. Now, I also have a formula here. Yep. So basically, it looks more complicated than it is. If we compare this to iteration 2, I mean, let's just keep things really simple, right? So if we compare this to iteration 2, iteration 2 basically just look like that, right? 95% marks for your implementation multiplied by your tests, plus 5% linting. This time, the only difference is we are multiplying your, like, the course tests by what looks kind of complicated, but it's essentially just saying your coverage. This here just means that 99% is enough to get 100. But forget that for a second, like, because it's a minor detail. I'm just going to write it like this. It's basically, you know, C cubed, right? In this case here, C cubed, oh, it has already been included in iteration 3. Anyway, I'll come back to that. Your coverage is a score from 0 to 1. Sorry, 0 to 1. So it could be 0, 0, 0.1, 0.2, 0.5, 1.0, right? The power effect essentially just means that, like, to give you an example, kind of explain this pretty clearly, 1 to the power of 3 is, surprise, surprise, 1. So if you get full coverage, then you get this 1. However, if you get 0.8 to the power of 3, it is 0.15. And if you get, say, 0.4 to the power of 3, it is 0.06. The reason the formula is set up based on a power is because, sorry. Give me a moment. I keep, someone is trying to call me and I need to tell them to go away because I keep hearing ringing in my ear. So what this is basically saying here is that if you get 1, you get 1. If you get 0.8, you get about half marks. If you get 0.4, you get basically 0, right? The purpose of this is quite straightforward. If you do a pretty bad job at code coverage, then you'll get like 0.5 code coverage. Like pretty, if I said like pretty really bad job at code coverage. If you do like a good job at code coverage, you'll get maybe like a 0.9. And if you do an excellent job, you get a 1. So the power effect purely just acknowledges the fact that getting 0.2 is not having done 20% of the work, and getting 0.8 is not doing 80% of the work, right? It's just like non-linear. You kind of might remember this from high school, where it's like if you get a 50 out of 100 in high school, you were basically, maybe it's different since I was in high school, but if you got like 50 out of 100 in like a, you know, science test, you know, in year 10, you were kind of like a bit of a slowpoke, right? Like in terms of, you know, 50 was like on the really low end of things. It's kind of like that. So it just is there to make that make sense. But it is multiplied by coverage. The relevance this has to you, which is really important, is that if you have a perfect implementation with bad tests, you will get a bad mark. If you have a bad implementation with amazing tests, i.e. all your bad implementation is covered by the tests, you will get a bad mark. Bad might be a bit dramatic here. Badder mark, right? Worse. However, if you have okay implementation with okay tests, you will get an okay mark. And if you have good implementation with good tests, you will get a good mark, kind of thing, right? So basically it's saying it's not enough to have good tests and a good implementation. You have to have both. That's really it. And we'll talk about code coverage again in a little bit. Iteration 3 has dry run. It has due dates. It has teamwork evaluations. Nothing new there. Perfectly fine. Now, Uzi has said, I think it's already included as of iteration 3 since no explicit any is already in my ESLint.json. I can't speak to that because I didn't add it. I guess the only relevance of that is that I'm not going to sit here and comment on it because I'm not familiar with all the details, but I'll simply say that why that should interest you as students is because that means that what this means is that if your TypeScript sucks, your linting will now fail. So how you nearly have to look at this then is that your ESLint and TypeScript marks seem to be quite combined then, because if this rule's already there, if you're not doing the TypeScript requirements that Yu Chao and co wants you to do, then you're going to get not only 0 for this, but you're going to get 0 for the linter as well. Because if this rule's already in the linter, then the linting's not going to pass. So let me see if it's actually there. I should do that before I yeah, right, it's right there. So think of I would now think of linting and TypeScript as one big chunky thing. Would be how I would approach it in my head, at least. All right, well, that's good. We've got a few things to talk about now. Namely, well, kind of not quite 4 things, but so here it is. Now, here's how it works. This here, Auth, section 5.8, we have a lecture on this, which we'll talk about in the next lecture. So if you're watching this video, it's the next lecture on Auth where we'll kind of unpack section 5.8. Section 5.5, Yu Chao week 8. Go watch Yu Chao's week 8 lectures. Yu Chao covers all of this in those lectures, as far as I understand or have been told. So go check that out because it kind of gives you all the tools you need to finish section 5.5, which is about creating new documents and stuff like that. If you have any questions about that one, I'm not handling those lectures this term, so it would be good to post those on the forum. It's not something I can necessarily advise on very well today. It's pretty well written down in the spec, which is good. But yes, it is mostly around the week 8 content on requirements and use cases and things like that. We'll talk about these 2 right now, though. So just to recap, we've got 3 things we're going to chat about today, but 2 in this lecture, 1 in the next lecture. Firstly, section 5.4, which is test coverage. Not a lot to say here, actually. I think the main thing is to point out that, we did this lecture back in week 7 on code coverage. And I mentioned in that lecture that when it came to code coverage, we basically did everything outside of a server. It was all kind of just like normal, non-server code coverage. With the server stuff, it is a little bit different. I made some allusion to this. Some of you have probably already figured it out, but I'll just kind of show you what I mean. If I just go and clone the repo, right, here. So can I clone this? Probably already cloned it. It's not there. That's good. Project backend. Hope that's not a trigger sentence for you. npm install. So it's pretty straightforward. What it's saying is when you go to run your server, instead of running npm start, I think we have it up here, right? You can run npm start to debug your server, right? Use API clients, stuff like that. Ooh, I'm probably on the wrong version of Node. Thought that'd be fine. That's weird. Are we up to 20 in the course yet? Not sure. Let me check. Someone will probably answer me anyway, but. So I'm just checking. 20, yeah, okay. Cool. Let me try again. Point is, you will need to open up another terminal, right? And what you might have done previously is you might have gone npm start, which it won't work because it's still installing. But you might have just done npm start to run your server. That's probably what you've done iteration 2. So I can still run npm start. It'll just start up my server, right? Server starting. However, if I run npm run ts node coverage, this is like npm start, except it's like ready for coverage checking now. So that if in a second terminal, I do npm run test, my tests that I've written, which aren't working, not sure why. I don't manage this code at the moment, but let's just pretend that works. I'm not sure. I might have screwed that up too with my weird npm installs. But the point is, you run your tests and they will run against this. So if I was to run that with, let me see if there's even a coverage folder. Should be. Let me just open this up real quick. npm run test, jest. Yeah, so I probably need to add dash coverage there so that when I run this now, okay, well, still wasn't too happy, but it ran all my tests. There's the coverage. You'll see there's now a folder called coverage. I can go discover all of that here. This won't work with npm start. It's a bit of a mess about. You can go look through the code if you want. Nothing's hidden from you, but there's a library called NYC that we kind of need because it's just not in the same terminal, you know? So essentially it's like the server's over here in one terminal and the tests are over here in another terminal. And normal coverage with like the week 7 content works by just like the test itself kind of imports the file and therefore it tracks it. It doesn't really work like that with servers, so you need this kind of other method that's a bit more complicated, but we've done all the work for you. So that's how you test coverage in this iteration. Remember, you should be looking, I believe it's statement coverage. Last time I checked. Just double check, that hasn't changed. Code coverage, yeah, statement coverage. So you're basically looking for this. That's your number there. 100 means 1, right? So it's, 100% is like 1. Yep. I repeated myself there. So that's coverage, really. Pretty straightforward. The next one, which is slightly more complicated to explain, would have to be the error raising topic. It's not even that much more complicated. So a big part of 1531, and in fact, these software engineering courses, one aspect of them that has been really important is the idea of refactoring and being able to modify your code, right? Now, you know about this because we had a lecture this term on trying to get your code to resist breaking when it inevitably changes. That was that lecture that was called like designing for maintainability. So you know that designing for maintainability is important. And we want to make that true in this assignment. So one thing that we've actually done in iteration 3 is that we've asked you to essentially make sure that you separate out your HTTP server and the application logic that exists. Now, I've heard this explained a whole bunch of different ways by different people, but I think a really great way to explain it, I've heard tutors starting to reiterate this recently too, which is good, is that, well, firstly, let me take a step back. There's a term that you'll hear used sometimes called application logic or business application logic. That is a term that describes like the code you write that's specific to your problem. So specific to the business, as in like it just wouldn't like, you couldn't really use it anywhere else, So like adding a Kahoot or adding questions, it's like you couldn't really transfer that to an app about, an online cheese store, like it's quite specific to your app. Whereas the HTTP level stuff, sometimes that stuff's a bit more generic, like the work you do on sessions or users, for instance, like, or the HTTP part of that, or sending stuff with JSON, that might be a bit more boilerplate and not really related as much. Now, yeah, just double checking about some of the examples. So here's kind of a great way of explaining it. So in iteration 2, what you probably did, which was totally fine at the time, we're not angry at you, right? It's just different, is that you would have come along probably, and you would have said, well, I've got, app.get, you would have put the route there. Then you would have simply called a function that you wrote in iteration 1, like admin auth register. And just to make this a little bit more concrete for you, you might have had something like this, where you say, /admin /auth /register, and you might have just called, admin auth register here with response dot query dot token and like response.query.email or like whatever else, right? Like you would have done something like this. And then you would have checked if there's an error, and if there's an error, you would have responded with status JSON 400. That's what you would have done in iteration 2. What we'd like you to do for iteration 3 is we'd like you to try and break that logic up a little bit more, because previously what your admin auth register function was probably doing, if it took in, say, a token and an email, I know it takes in more than that, is it would have first been checking, like, check if the token is valid, and then it would have said, oh, there's no token on the admin auth register. So let me think of is it admin quiz create? Let me just check. Can't remember all the names off the top of my head. Yeah, it's just post admin quiz. Okay, so like let's say you're making a new quiz, right? So iteration 2, you've got like post admin quiz, and it's called like admin quiz create, takes in a token, takes in a name, right? They're both going to be in the body because it's a post request. Pretty straightforward stuff. And then you have this here, and it's going to take in a token and a name. And like first thing you do is check if the token is valid. And then if it is valid, then you go and, check that the name is valid. Now, what's actually happening here is that you've written this one function that goes and does a whole bunch of stuff. Now, this isn't strictly the worst thing in the world, right? Like, it's not like it's a fundamentally broken thing, but an interesting intellectual exercise for you all in iteration 3 is to think about how to break up your code into more what you might call, sometimes we call it separation of concerns, or just modularity is one way to think about it, and to say, you know what, admin quiz create as a function should be really focused on creating the quiz. It shouldn't be focused on figuring out whether the person who's made the HTTP request is allowed to create the quiz. So I might go and create another function here called, is valid, user or something, right? I'm not trying to tell you everything. And here I'll say, check valid user, and I'll pass in request.body.token to that, like this. And now what I say, instead of my, response 401, I can simply say, you know what, if it's not a valid user, then what I'd really like to do is just to go response.status 401 or something like this, right? And you could kind of break this up a little bit more. Or you could say, check valid token, might be a good example. Is valid token, like this. Sweet, is valid token. We need to return after that one if we want to. You can also structure your logic a different way. Now in this case, we don't really need to throw a 403 because there's no such thing as like invalid. The user's not permissioned to create a quiz because either the token's valid or not. Like once you've established it's a user, they can create a quiz, right? But other routes, you might have to do something similar that's like, is allowed to, right? Where we actually check, are they even allowed to do that thing? Where if they're not, check owns quiz, where we also pass in, say, or, maybe this will return like a user ID or something. Or it'll return null if it doesn't work, right? And then we pass in the user ID to checking they own the quiz. And we also pass in the quiz ID. Obviously, this doesn't make sense because it's creating a quiz and I'm not trying to verbatim write the code for you. I'm trying to make you think about it. This might be like quiz ID or something like that. And, if they're not allowed to modify the quiz, then you return a 403. And then you get into the admin quiz create. And what you do is admin quiz create should no longer worry about the token. It's simply knowing about a user ID. And it's simply saying, yes, this user ID is now okay. And what we've done is we've separated out our code so that there's part of the code that's about, is this a token? There's part of the code that's about, is this valid token reflecting a person that's allowed to do the thing we want to do? Then the last part's about actually doing the thing. And again, it's not a universally right way to write programming, but in general, there's a lot of value in the idea of, you'll hear this a lot as like, one function should have one job. And you don't really want to kind of mess those things up. So what this ends up being is that your server file in theory gets bigger, but the size of your functions gets smaller that are being called, and maybe there's some extra functions. That's what we're asking there. If we go back to the spec, they kind of, well, that's to do with exceptions, I guess, sorry. Yeah, no, okay, this is a slightly different thing. double checking I've got this right. I think it's just the top part of that. I probably shouldn't have really pointed to that code example. It's really this part here, right, that I'm talking about. This code example is useful to start with, but the before and after is not what I'm talking about here. It's really this part. Your server never passes in any request or response object to subsequent functions. Now, some groups have, really actually take this stuff even further, and you'll see them do something where they'll say, admin quiz create, and they will simply say, return admin quiz create, and they'll just pass in request and response straight to it. But that's the most extreme example. And again, this isn't good because now your application logic is having to concern itself with the behaviors and doings of an HTTP server. So we don't want to do that. We want to do what I've talked about here. We want to break it up into different pieces. Now, the cool thing about this assignment is there's only really 3 errors that we've said that you need to worry about throwing, which is 400, 401, and 403. That's written in the spec, right? Unless something's changed. I don't think it has, though, as far as I can tell. They're right there. They're the 3 errors you have to be concerned with. And the cool thing is that 401 errors are a really specific type of error. 403 errors are a really specific type of error. Very easy to kind of check at the start. And then any error that follows after that's typically going to be a 400 because of bad user input, So it means that most of your routes can kind of look like this thing where like you might check the token for most routes except for, login and register. Then if you've checked the token, if there's any permissioned routes that require some kind of checking, then there's another check you have to do to determine if it's 403. And then after that, you can just check all the other things that they've done as 400s. Now, your natural reaction to this might be like, cool, but this seems like a lot of code, right? A lot of redundant code. Then it's like, well, Hayden back in week 5 said designing for maintainability is about not repeating yourself. Repeating yourself is really tiring. Well, firstly, I'd say this refactor probably doesn't cause a lot of you to repeat yourself because you probably had similar code like this, throughout your, functions like admin quiz create. However, without telling you too explicitly, one thing that I would encourage you all to go back and check out, hopefully I don't have to log in, yay, is you go back, sad. All right, is you go back to the lecture advanced functions, go check this lecture out, and you go all the way towards the end here, and you'll see a topic we did, which I'm sure many of you remember, called higher order functions. This is a pretty great way to clean up your code really elegantly if you find the functions part to be not that good. Because obviously we've done a good job here of abstracting this, but it still feels quite lengthy. You can make this significantly easier by like Express Server JavaScript wrapper. Or, I wonder if it works properly here. So like, I'm just kind of Googling this here. Yeah, this will kind of, well, they're trying to use middleware here. I don't want to. Yeah, maybe that can work. There's so many different ways to do this, honestly, and it's kind of more advanced. I don't want to imply that it's a requirement. So the stuff I've just mentioned about higher order components, it's not a requirement that groups, focus on that explicitly. It's more that if you kind of are like, well, I see what they're trying to do, but it makes my code more ugly. It's like, well, yeah, but there's ways you can do it without making your code look ugly, which is important. You'll also remember earlier in the term we talked about exceptions. They weren't introduced into the project at all, though. So another thing we'd like you to start doing in this particular project is to start throwing exceptions too. So this base code example that I kind of grabbed and ran with, the before and after, what you'll notice is that instead of returning an error block, we're now saying you should throw a new error like that and catch it and handle it that way. This will actually probably make some of your coding a little bit easier, and it will also allow you to create more layers in your code, because one of the benefits of exceptions is that you can go and create like a function that calls another function that checks another error, etc., and you know that that can kind of bubble all the way up in the application. So in summary there, it's basically need to throw exceptions. That's one refactor we want you to make, so no more returning error. This is something that the auto marker will not pick up on because it's a refactor, and refactors do not change the external behavior of an application, just how it's structured and written. And like the main difference is just going to be in what your tutor sees when they mark the code, right? So don't feel like it's going to break anything. I wouldn't necessarily say do this last, but the main point is it's not tied to auto marking. This is also not tied to auto marking. This whole section is not tied to auto marking at all. It will simply be your tutors manually reviewing your code when it comes to the marking. That's really important. Now, that's pretty much at the end. The only thing that we haven't gone through in iteration 3 is about Auth, which is the next lecture, and we'll do that after the break. But just before we wrap up the iteration 3 lecture, does anyone have any questions at all? Do they want to ask about iteration 3 and the spec or anything like that? Someone says yes, they have a question. I'm looking forward to the question then. Okay, so the question is, so for the admin quiz session list route, all right, so this will be one of the new routes, quiz session, I think it's sessions, okay. We got a list of sessions. If a quiz doesn't have any inactive sessions, should the route still list the empty inactive sessions array? It's a good question. I would post it on the forum just to check, but I think, look, if it's not defined in the spec, then you are very likely to be in a situation where it's simply not tested, right? So what I mean by that is like, if like the question makes sense, should inactive sessions be empty or should the whole key just not exist? Well, my point is that if it's not defined in the spec how it should behave, then there's a 99% chance there's no auto marking for it. What that means is that if there was an auto mark that created a scenario where there was no inactive sessions, it would not even be checking the array. It would not check if it exists. It would not check what's in there. It just wouldn't be checked. That kind of comes back to what we talked about in an earlier lecture around the term user-defined implementation. So if it's not in the spec, it would either be, considered to be undefined behavior or user-defined implementation. Though in reality, if you just think about it practically, you would normally include an empty array, because if it's the 1%, then you just lose the mark and you get to fight about it on the forum, and the course staff look at it and go, oh, that's a good point. We never told them what to do there. So the 1% is not a mark loss. It's never perfect, right? Like people that work on this are not perfect individuals. But I would just include it anyway, because not that it matters about the auto mark. If it's not specified in the spec, then you can do what you want. But I would still include it, because if you just think about it from the perspective of an application, like someone using your code, what would you want? Like if you had a function that you knew was going to give you an array of stuff, you'd always hope it gives you an array. It doesn't, like when it's like, oh, the array's empty, I guess I'll give you nothing. Like an empty array has meaning, so you might as well give it an empty array. That would be my comment there. Yeah, and Princess Sakuno says, wait, so just to confirm, we should throw new errors, but try catch is not compulsory, and this was already answered to. You do need to catch it, otherwise the program will crash. So instead of returning an error object with a key and a value, you will now be simply throwing an error and catching it yourself and then using that to return it. The examples in the spec are really clear on that. So go check out those examples that we were talking to earlier. Yeah, cool. Well, we've just reached kind of time for this one. Let's take a 10-minute break. Then we'll get straight back to it for the next part of the lecture. Hopefully that was insightful. Otherwise, we'll chat soon. Thanks all. If you have any other questions, post on the forum. The team's always happy to help out. Hi everyone, welcome back. Hope you had a nice little break. We're going to get stuck back into this. Actually, give me a sec. I just need to... One moment. I have misplaced something I need. My water bottle. One sec. Hello. I had one job over the break, and it was to get this, and I left it in the kitchen. All right, let's get into it. Okay, so lecture 9.2. This is our last full stack lecture. It's on the topic of Auth. It's a topic that I think I care about pretty deeply. It's not really a security lecture strictly. I'd say it's a bit of a programming lecture that makes you just think a little bit for a moment, like someone with a security background. So that's kind of the aim of today. But let's actually talk about it in more detail. So basic security is an important step in building good software, right? You can't really afford these days to not have decent security. The shortest story I'd tell you, if you read a textbook about software engineering from 1999 or 2002, they're not going to spend a lot of time talking about security, but why would they? Like the risks and how software is built now is just so different. Like I'm trying to think of, a good example is back in the day, maybe you hired a VHS tape or a DVD, and you copied the DVD, and it's like, okay, you copied it. What are you going to do? Spend thousands of dollars like mass producing it and selling it? How, like on like eBay or something? And technology's just gotten so good now that software's so exposed comparatively now. You got things like Netflix, right? Or someone else. Like, what if you could bypass Netflix login and just share that around on Reddit, and then suddenly a million people could get access to it. Seen this pretty commonly with things like on the topic of Netflix, people figuring out hacks to get it cheaper overseas. The way information is distributed, and also the fact that software is more and more cloud-based, and that means less and less is on the client, and more of it's on the server, is also like a massive deal. So software is just more exposed than ever, and that means that more and more, year by year, the degree to which, if we don't get basic security things right, we screw ourselves up is pretty high. Now, the good news, on the contrary to that, is that security now more than ever is actually probably dealt with for us. When I started programming a long time ago, there was a lot that I learned about security that is kind of useless now, because software is just like a lot better at stuff. You'll see these things online, like, good examples like SQL injections. Some of you have probably heard of that. You might have heard of like, string format attacks or buffer overflows and all these kinds of interesting things. But like, so much software now is just so high level and has so many guardrails and abstractions that the majority of the time, not all the time by any stretch, a lot of security is dealt with for us. However, there's still a lot of problems now, because even though we have all these amazing systems and amazing tools, and we're going to look at some of them today, there's a lot of problems because people just don't use them properly. It's kind of like, there's all these, like, think of it like your home, right? There's all these things out there, like we got security cameras and all these, what was like Crim Safe. I don't know if it's a nostalgic memory for me. It's not safe if it's not Crim Safe kind of ads on TV. Lots and lots of stuff, like it's like I learned a few weeks ago how like it was so interesting to me. These like their smart bulbs can, like, they have little mics in them now, so they can kind of, smart bulbs can act as like home intruder alarms. And I was just like, damn. So there's it's like that in software. There's so many tools out there, but if you don't use them right, they're kind of useless. And in some ways, it gets pretty bad because we have so many tools around us that if we aren't really cognizant that they need to be used right, sometimes we can actually end up more unsafe because we're not using them properly, right? Like, imagine that stupid smart bulb again. It's like, what if you just don't know how to use the app, or you configured it wrong? What if you just set it up wrong? Even though it's a perfect device, you can just screw it up. So I think the main takeaway from what I want to leave you all with today is that basic security is important. There's great tools out there that help us solve a lot of problems nowadays. We're going to give you a couple things to think about in the course, just to think about, very minor things for the project that will just pique your interest. And hopefully in the future, when you go do something else, you'll go, oh, I remember when I had to think a little bit about security for a while. Maybe I should think about it a little bit more. Cool. Now, the reason the lecture is called Auth is because there's kind of two really key concepts that both start with Auth. It's a pretty dumb name. One of them is called authentication. The other one's called authorization. Authentication is essentially the process of identifying who you are, right? Like this can be done a whole bunch of different ways, like a username and password, a two-factor authentication phone thing, showing someone your driver's license or a passport, whatever they are. It's about the process of being like, I don't know who you are. Give us some information. And if you give us enough information or you give it to us the right way, et cetera, we'll be like, yep, I know who you are exactly. So I turn up, I say, I'm Hayden, and they go, prove it. And then I go, here's some stuff. And they go, okay, that'll do. Sounds good. We've authenticated that you're Hayden. Authorization is a separate concept, which is kind of after that, which is like, okay, we know you're Hayden, but are you allowed to do the thing? Now, a lot of you kind of can understand this just by having walked around UNSW before. There's a lot of doors at UNSW, and you can tap on the door. Some doors will let you in, some doors won't let you in. Some doors will let you in at random times, and other doors won't, right? And that's essentially authorization. It's the processing of like determining an authenticated user's access privileges. Now, we don't really talk about authorization in this lecture at all. It's just worth kind of flagging because I think that without kind of explicitly saying that, there'd be a lot of you, and I'd be included, that would kind of think that they're essentially just the same way of saying something, like verification or authentication, like you'd be like, sound the same. But they are kind of quite different. And again, just a reminder before we go much further, UNSW does have some cybersecurity courses on various of these topics. Yeah, I haven't really done a lot of them in a while, but COMP1531 is a very popular course. It's not very technical. There's a technical version of the course called COMP6841. That's probably what a lot of you should probably, it's probably what the average student should take is COMP6841, because having a little bit of technical background is good, and it's a nice, light, easy course that doesn't really alienate those like me who don't really like want to work in security, but like I want to go build amazing products for people. But I need to know a little bit about it to do my job properly, So that's a great starting point, at least I would say, for the average student. Some of you'll do more, some of you'll do less. Yep, we kind of talked about that already. There's a different example. Okay, so authentication. What's the most basic approach in the context of your project, right? Iteration 1, iteration 2, which is that a user registers to your app, you store their username and password, right? It's probably what you did, iteration 1. They log in, or they request to log in, they request to authenticate themselves, and then you simply look at the password they gave you as part of the post request, and you compare it to the password you store in the database. And if they match, you have entered the right password, and your code might look something like this in iteration 2, TypeScript converted. You have your data with users. Let's say users an object where the email is the key, and then you have the string is the password. Your data structures are probably more complicated than this. And then you have the actual data structure. You have a register function, a login function. The register function stores the password. The login function checks if the password that was entered matches the password in the user email address. Now, what's wrong with this code? That's the question that I'm going to ask you now. Some of you know it because you've seen it since the start. Some of you know it because you've read the iteration 3 spec. And some of you are about to get a lovely surprise, but I imagine there's a bunch of you that know it. So help me out in the comments. What's wrong with this code? What is a potential problem with it? 29 people in this stream. Waiting for some inspiration, everyone. No token. The token isn't really part of login and register. It's a good guess. Good guess. A lot of other functions that would be true for. William says it stores the passwords in plain text. Uzi says passwords are stored in plain text. I always find this funny. Like, they're great answers, and plain text is a funny word. Actually, Thomas also made a comment about using an object like that rather than array is a bad thing. Can you tell me more about that? I'd love to hear your view on that. But yeah, so we got this idea of plain text, and it's a funny word. But plain text is a word that we will typically use just to describe the fact that it's just written in, ASCII literally as people would understand it. Bit of a broad word. You could have an interesting question like, is a JSON string plain text? Maybe. Contains plain text. Is it plain text itself? I don't really know if there's a clear answer on that. But point is, plain text, we're just storing the password. I'd say we're storing the password verbatim. We're literally taking it and just like storing it in the data structure. And that's not really good. For all the nerds out there, in this particular example, it's being stored in a variable, which is fine. Like, there's actually lots of sensitive data stored in RAM all the time. That's just how RAM works, so when you actually go and put it in that variable, it's like, well, yeah, technically it's fine. However, where the sensitivity lies is the second you put it in a piece of data that's exposed beyond that function. Some examples would be if you put it in a memory buffer, if you put it persisted on disk, like you had to do in iteration 2, or if you stored it in an SQL database. Once it's on a hard drive, that's really bad, particularly if it's just written down. And you know this, right? Like, if you ever opened up your database.json file and you've seen passwords there, and you're like, no, that's not good. That'd suck if I entered my password there and someone else saw it. Then I'm sure a couple of you accidentally pushed it to Git. It's like, okay, well, now this data is getting sent around the internet. So we don't really like that idea at all. It's quite bad. We need a way to hide the password. But hiding the password is not really going to be the most trivial thing for us. Thankfully, there are some libraries that make it pretty easy. The next thing to talk about is about how we're actually going to hide the information. And on the topic of hiding, there's two kind of key phrases that I want to get across to you. Encryption and hashing are two very different terms, but they are both processes of taking plain text information and concealing it by turning it into seemingly random strings of characters. So you can take something like, fox, or the red fox jumps over the blue dog. You can encrypt it or hash it somehow, and it turns into what looks like gibberish, right? And to a normal person, they see this and they're like, I don't know what that means. And because of a lot of complicated mathematics, there's a few courses in the math school you can actually go and study that gets into the mathematics of this. It is really, really difficult, to the point of being essentially impossible to ever get something on this side here, and without certain, access to some secret information, ever figure out what it originally used to be. You got to remember that a lot of computer science is rooted in mathematics. This is true for cryptography. This is true for artificial intelligence. If you bury it down, if you go very, very deep, burrow down into it, it's all just maths at the end of the day. So if you're someone who wants to understand this stuff more than just at an abstract level, I think there's a course called Finite Mathematics. Hopefully it's still around. But nonetheless, we have this capacity to kind of, hide information. Now, the difference between encryption and hashing is the reversibility of things. So hashing is the process of taking something and sending it down a one-way street into gibberish. And once it's gibberish, no one can ever undo that. In fact, like it's just literally, there's no method for it. However, encryption is a little bit different because you can undo it. Now, naturally, how you undo it is that you have to contain some kind of, key. It's a little bit like, I always like to think about it. It's like, so many different ways. Anytime something is reversible, it's naturally going to be finitely less secure, right? Like, if you're worried about someone breaking into your house, you can always literally glue your door shut or weld it shut or bolt it shut with studs or something that you can't undo. Yeah, great, cool. You're super safe because you can't even undo your own door now. You can't even get out of your own home. So yeah, it's going to be safer. However, it's not always practical to do that. Sometimes we just want to be able to put a lock on something. Sometimes we want to be able to secure something and we want to have a way to unlock it. However, the downside of that is that every time we want something to be reversible, every time we want to be able to turn something really sensitive into something super gibberish and seemingly random and we want to convert it back, we need some way to do that. And that means we need a key, right? Just the same way if you lock a door in your home, you need a key to get back in. And when we have that key, that's something that we can lose. That's something someone can accidentally get. That's someone can accidentally steal. So, the question I've gotten in previous lectures is like, why would we ever want something that's irreversible when you have stuff that's reversible? And it's simple. If it's reversible, you have another little bit of surface area that someone can come and exploit you on. Whereas if it isn't reversible, then, if you can't do it, then no one can, kind of thing. So reversibility makes it finitely less secure, but it provides the convenience of being able to reverse it. Good examples of reversible, hiding of information, i.e. encryption, is when you store data somewhere that's secure, right? So a good example, I think iCloud is the one I know about this. It's like iCloud uses your password to encrypt. Your password is your little key. So when you put stuff up in iCloud, Apple can't see it. The only way they can see it is if they get the key, and the key is just your password. I'm pretty sure that's the case. I know there was a thing a while ago where Apple was like, there's a bunch of information that if you literally lose your password and all your backups or whatever, and you can't get into your account, they can't get your data back or something like that, because Apple was like, well, we literally can't, because like we don't have the ability to. Some providers will be different, so let's say, I don't know, there'll be another provider like a Dropbox or something, and they'll encrypt all your data. They'll make it seemingly gibberish. So it's sitting on hard drives at, Dropbox, headquarters or something like Dropbox. And you can get it with your password, but if you forget your password or something, they might have the ability to decrypt it still, which means they have some, high powered keys themselves, right? It's the same if anyone's ever had a rental before or been in a rental, the real estate's got a set of keys at the real estate. They can come into your house at any time. They just don't, because they don't want to run out of business. Right? Because if you had a real estate agent, LJ Hooker, started coming into people's houses, no one would use them anymore, right? It's really no different to a lot of these large companies, is that they encrypt a lot of your data, and a lot of these companies could probably get that data, get all your Instagram messages and stuff, but that would be bad, so they don't do it, right? Markets correct themselves. So we're not going to talk about encryption today. It's actually a lot more complicated. It's a really great thing to go and do in some more security courses, whether that's comp-based or math-based. We're going to talk about hashing, though. Hashing is a part of encryption generally, and it's really straightforward to talk about. So here is a library. It's baked into Node.js, the interpreter, and there's this library called crypto. It has a built-in function called create hash, and what you do is you can actually there's a lot of different types of functions that can turn things into gibberish, right? Different methods. Maybe if I wanted to turn the word dog into gibberish, I'd have method 1 over here where it turns it into A, B, C, D, F, G, and I have a second method over here that turns it into P, Q, R, S, T, U, V, So there's different kind of ways we can map the information we want, or plain text, to this kind of seemingly gibberish thing. SHA-256, SHA-256 is one of them. It's a pretty common one these days. These used to be very different in the past, and they'll always continue to evolve as technology improves and our needs change. But we have a piece of code here where I literally can copy that. I don't need NPM because crypto is part of, I'm pretty sure, those core 27 Node.js libraries. I'm just going to call it hash.ts. I probably don't need the TS part. I'll just run it with Node. Don't really need the TS part today. I don't know why I did it this way. I thought it would be fun to just do it plainly, but we've got the, sometimes I like showing you how simple code is. Like, you don't really need a lot of big complicated stuff, but I've just realized it's slightly more. There you go. There's the output. So I've got this file here. It imports the crypto library. We have this function get hash of, where we give it plain text and it jams it in this big function. And then we take a message, which is Big Mac secret source, and we simply get the hash of it. And if I just print out maybe the message and the hash, you'll see that we turn Big Mac secret source into this long random piece of gibberish here, which is really good. Now just to unpack this line. This is creating a particular function that is ready to hash something. This is giving it the information to hash, and then this is us saying, I don't want that in binary. I'd really like that in just like a hex format. Hex is great because it's ASCII characters, right? Whereas binary doesn't really have a great ASCII representation as well. So we just generated a hash, get hash of, convert a Big Mac secret sauce to that. Perfect. What could be better than that? How do we apply this to our authentication issue? I'd love to hear your thoughts in the comments as well. I'm just going to quickly answer Thomas's comments, but tell me how you do this. How would you apply hashing here? Thomas says the email, this is back a few slides ago, the email is a string type, and so data.user's email is using the email as the property key for the object. This is bad practice. Yeah, I mean, I wouldn't say it's, unless you know something I don't, which is very plausible because I don't know everything by any stretch of the imagination, but I would say that's fine. I'd say like using a map string is different. Like you probably got some more abstract checks, or it might be easier to write some code, but maps aren't serializable either, unless that's a recent update. Not sure. I wouldn't outright call it bad practice unless I'm just uninformed on the topic. But yeah, I mean, if someone did a map, I'd be like, cool, use the features of JavaScript to the best of your ability. And yes, and Thomas jumped the gun and got really, nailed what we're going to do with the hashing part. So not a lot of exciting attention in the chat. Maybe there's just a bit of a YouTube delay, but let me show you. So basically what we would do is instead of just storing the password here in the register array, we're going to store the hash of it. And then when we check the password, we're simply going to check the hash of it. Now, this is the funny thing about hashing. Hashing is a great way to hide information where you never actually explicitly need to get the hidden information and return it back to normal information. And this is really true for passwords, because if you think about how a password works, you can give me a password when you sign up. I can hash it into complete gibberish. I can store that gibberish. I'll never understand what it is. I'll never be able to do anything with it. But when you go to log in, I don't actually need to decrypt that gibberish to see if the password's right, because I can just take your password and hash it again. Because hashing is deterministic. For the same string and the same hash function, it will return the same output every time. So that's great, because I'm like, well, if you've given me the right password, then in theory, if I try to hash it again, I should get the same result. And then if it turns out it's the same result, I go, great. That's really good. And now I've been able to store your password, and you've been able to give me your password when you try and log in. But I've never actually had to store the real password anywhere. So I can authenticate you without the persistent storage of your password. Now, to my previous point, yes, I have access to your password in the code, in RAM somewhere, naturally, because in the login function, I pass in a password string here, and I use it here, right? Like it exists in the code. However, I'm not storing it anywhere, and I don't need to store it anywhere. I only need to store the hash, and that's really important. Pretty simple stuff, actually. Authorization, we said we were going to cover later. Are there any questions about authentication? Otherwise, I'll kind of just jump straight back to the iteration 3 spec and talk about auth in that context. Because I just want to get back to that particular section of the spec, which is here. Anyway, if you have questions, pass them through. Okay, so section 5.8 of iteration 3, it's called safer user sessions and secure passwords. There are 3 things that we're asking you to do for iteration 3 to make your application more safe and secure. The first one's really simple. We want you to secure passwords and store them in a hashed form. Great, easy done. We just did that. We literally gave you the code for that basically in the lecture. So we want you to store hashes of passwords. Your tutor will be manually checking that. The next thing we want you to do is to store more random user session IDs. This one's really important because when you have a session ID, like let's imagine right now, like if your token, right? If your token is literally just the thing that says session ID 1, that is all you're using to authenticate right now. As in what all someone has to do to like if I get session 12, all I have to do is send from my front end to your server an object with session 12 in it. And suddenly like I have session 12. And you know what's really, you think like a bad person here. They could kind of come along with the session ID and change it and say, you know what, I want to change that from 12 to 13. And then let's imagine it's not me, it's Yuchao who has session 13 that was generated for her. Now I can just pretend to be Yuchao. So the lack of randomness that can exist, right, in in sessions is quite dangerous. Now, there's two ways around this. Number one is using a randomly generated session ID. A bunch of you have already gonna do that. And the other one is to just return a hash of the session ID as well, or some kind of similar thing, right? But they both mean the same thing. Like using a hash here is no real. It really has no other value except that it's just producing a random number. You don't really have to hash anything. But it isn't like we can go deeper on this. We used to kind of go deeper on this and try and say, your sessions should be tamper proof, etc. But we don't really feel like that is adequate. Like that's just a lot of burden on you to think about that. If you are interested in making your sessions truly tamper proof without having to use random numbers, I would encourage you to go and have a look at JSON web tokens. We used to teach these in the course years ago. It's a very interesting concept. It's one of those things where it really doesn't make any sense until it makes sense. Then it makes a remarkable amount of sense, and it's really quite straightforward. I'm not going to explain them here, but they're a great way to make sure that your tokens are tamper-proof. Because basically the way to imagine it's like, it's a little bit like, we kind of get this, right? Like fake IDs. I have a driver's license. Okay, why don't I go and change the number on the driver's license and use my friend's photo? And then I am my friend. I turn up and I'm like, yep, I'm that person. And then I change my own face, right? Like people can tamper with authentication methods all the time. How do you make them tamper-proof? That's very difficult to do in a physical world, but in a software world, we have methods like JSON web tokens and stuff that mean that you can say my session ID is 12, and if someone changes it to 13, you're like, nah, you changed that. I can tell. I have my secrets, and they make it clear that you have touched this when you shouldn't have. In the absence of that, though, because that is quite complicated for, say, a first-year student to get their head around on top of everything else, what we're simply asking you to do is make sure that your session IDs, if they're not already, are quite random. What randomness does is it essentially means that the probability of someone guessing someone else's session ID is so low that it's essentially not going to happen. Could, in theory. It could also happen far more likely if someone has the capacity to try a million different session IDs, which is one area that your system could be weak in. But we're not going into that level of detail for iteration 3. We're just saying make sure they're random. And some groups might have already done these two. The last thing for iteration 3 is avoiding tokens being exposed in the URL. So one thing that's really tricky is in iteration 2, we told you that you're going to make a bunch of get requests and delete requests where you send the token in as a requester to the server. As you capture it with request.query. And then we had our post and put ones, which you capture with request.body. Now, the way that an HTTP request works, right, structurally, is that you basically have up here, you have your URL and address and things like this that you want to access. And then you send along with that URL a bucket of stuff. And this bucket of stuff will include things like the body. Now, why this is particularly interesting is that when they started encrypting all web traffic, right, what they started doing was they essentially started encrypting this part, this box here. Encrypting means that when you send stuff over the internet nowadays, it's all kind of hidden away in theory. From people like your neighbors or anyone else who kind of was to stumble upon, someone tapped into the wires on the street and started reading packets out of a wire, they wouldn't be able to access it. Now, this behaves a lot like envelopes in the sense that when you post an envelope sealed, your sensitive letter is in there, but the address still needs to be on the packet because someone needs to know where the hell it needs to go to. And that's the same for the URL and our query parameters. So whenever you send stuff in the query, it's sent in the clear, basically. And that means that it's like written on the outside of the envelope, whereas the body's inside the envelope itself, hidden away. Now, this can be particularly bad because what that means is that the way groups have set up things in iteration 2 is that you've actually been, the way you've done it with GET requests means that your token is going to be sent over open network for people. So if someone at your home or anywhere in between on the internet decides to try and tap into your request, UNSW, for instance, they could get that data in the URL. That's not great because it basically contains authentication information, because your token is basically a piece of authentication information. So we don't want to include that stuff in the URL at all. In general, we don't really want to include a lot in the URL unless we absolutely need to. The usual piece of education I like to remind people, because I feel like awareness of this is never the strongest. It's important to remember that your internet traffic is encrypted, but the URLs that are being sent are not. I know I've said that before, but just to reiterate, what that means very clearly is that, let's just say for a second that the Australian government can't access your encrypted data. I don't know if they can. I never really know. I always read the news about it. But let's just say for argument's sake, they can't, or Telstra, they can't see your encrypted data, say. What that means is if you're on Instagram and you are messaging people, in general, in theory, people can't read your messages except you and the person who's reading the message. Or, I guess Instagram at either end. But basically, like, Telstra can't, in theory, like, just read your messages on Instagram because it's encrypted. And it's encrypted with 2 locks that are only available to, like, you and the other person. I'm oversimplifying a bunch of stuff here. However, the URLs are not. And what that means is that somewhere out there is a log at your ISP, at the Australian government, of every profile you access. So if you're like, I'm visiting Yuchao's Instagram profile every day, but everything's encrypted these days, so no one knows. It's like, no, they know what URLs you're accessing all the time. I think this is really important. Like, I'm not a big kind of libertarian or security nut by any stretch of the imagination, but I like to think about it. And I think it is just important to realize that, your actions in general are at least partly understood. And this is more of a passion project for me. It doesn't really relate to the course, but the one I remember that really stuck out to me as an example when they were first talking about this in legislation a long time ago was this phrase that was like, we know that you called Lifeline at 2 a.m, but we don't know what you talked about, which I think summarizes the topic really well, is that there's always a lot of good information, like anything that you do around like where you're trying to connect to, in terms of URLs, phone numbers, all that stuff is always just totally, you just have to assume that everyone is capable of seeing that, right? It's really the box inside that, the data you send as part of that. Now, the reason that's relevant to the project is because, back to the start, the token is sent through the query. So in iteration 3, to create a more industrial approach, which is how this would work in most applications you use, it doesn't actually send the token in the query, and it doesn't send it in the body either, because the body only works for post and put. It actually sends it in another part of this like payload that exists called headers. Headers are essentially a way of saying, like, here's the metadata associated with the request, and it's not really the core body. You can see those on many web pages. I can probably see them here pretty quickly. If I just say, what's a good example? If I just refresh this page, give it a sec. You'll see there's lots and lots of stuff here, but this original page, you'll see that there's like headers that are sent, and the headers are things like, here's the request URL. It's like, there's the path. Here's a bunch of content types to accept. It's sending a whole bunch of other boring networky web stuff. Cookie. Great. I probably have to log out now that you've seen that. Oh, I always hate when I do that in lectures. Anyway, that's all the data there. Log out pretty quick. Or anyone can copy that. Anyway, we're gonna sign out now. I just got to open this in another tab. Every time. Cool. Yeah, so it's all in the headers instead. And that just means that, like, it's a very simple change actually, because in iteration 2, you were doing things like saying, const token equals request.query, or you're doing the same thing for request.body. And all we're telling you, it's actually really easy because the front end handles the sending of it on the header, is that for this iteration, every route that you have should be sending it via request.header token. But yeah, I mean, const token equals that. You just capture it like that for every single route. Doesn't matter if it's get, post, put, delete, etc. It's all handled for you. And that just means that the sending of your token is no longer exposed on the get and delete request. So it's just good practice. And they're very small changes. They're just the 3 changes you have to make. Are there any questions about that? Because that pretty much kind of covers everything to do with auth and the spec. It's pretty light content. It used to be more complicated, but we've trimmed it down. Otherwise, I'll just answer all the questions left in the chat for today. There's a few interesting conversations going on about security. Yeah, I mean, firstly, Thomas, just to round out your comments around a map. I mean, yes, I think map has more functionality. I think it's very hard to say, like, it's outright bad. It would depend on what you're using it for. Like, if you know there's not going to be conflicts and you don't need to iterate through it, then it's a different thing. You might need to iterate through it for the project, say, like, I think everyone should just learn about both and try and figure out what works best for the application for sure. I think one thing just to point out to people while we're killing the last few minutes here, I normally talk about this in the lecture. I thought I would skip it today, but it's worth mentioning that because people might ask these things about, oh, well, you can't reverse a, let's go back to our code for a second, wherever it is. I've got my like hash here, right? So I've got my hash file here. And you think, well, okay, let me encrypt something basic like Apple. All right. So sorry, not encrypt. I hash Apple and I get this kind of thing. And it's like, okay, well, no one mathematically can take that and figure out that it was from Apple. Some funky math. You should really go look into it if you're really curious about how exactly that works. However, what people do is what they literally go and make for loops with like every possible word, like apple and orange and pear, etc. Please, there we go. And what they do is they basically make these logs of like apple is this hash and there is another hash. I could do this right here, right, where I go and say, well, okay, that's apple, and then apple 2 is this. Yeah, okay, it's a different hash, and then apple 3 is this, and they basically go and make every permutation, right? So they kind of like reverse engineer it the slow way. And what then they do is they create these little libraries where someone can go and put in a hash and they can actually see where it started. That's not because they're taking this and turning it into that. It's because they just have a absolutely massive log of every one of these and what it maps to, and they're just reversing the map, right? It's not very difficult. You could do this right now. You could make a whole list of it. You could put it in a CSV if you want to. And this is why at the core of it, we need long passwords. Because if I write a password, this is a very long password. And I try and say, okay, well, here's this hash, tell me what it is. It's like, I don't know what it is. And you might think, well, how not? Surely they've tried that. Like, surely across the entire world on, Russia and China or this, whatever, or like someone's figured it out. It's like, without going too far into it, mathematically, the number of passwords you would have to try are just ferocious. So take my password here, right? This is a very long password. That is what, 6, 7, 11, 15 plus another 7. That's 22 characters long. Now, if I think about, I've got, 52 characters, A to Z, uppercase, lowercase, and then another 10 numbers, and then another 20, we'll call it, 10 special characters, right? And I've got 72 characters, and they're 22, digits long. That's a significant amount of possible passwords I could get, right? And let's imagine, for argument's sake, you could generate the hashes to 1 billion passwords, like 100 million passwords a second, right? You could hash 100 million different unique passwords. That's how many seconds it would take. That's how many minutes it'll take. That's how many hours it'll take. That's how many days it'll take. That's how many years it'll take. And then this is how many billions of years it'll take. Like the numbers are just like unfathomable, So that is why long passwords work, because it's simply, you can never like reverse engineer a hash, in theory. However, you can build out possibilities, but just like any building out of possibilities, it just gets exponentially harder. So that's why we like long passwords. That's how people get around issues with short passwords. Got one last question for today. Random Name says, about last lecture, should checking if a user owns a quiz 403 be done in the server or the function since it uses user ID? my comments to you would be that if you actually have a look at what checking if a user owns a quiz, there's like most 403 errors are basically going to be like, can this user view this quiz or can they edit a quiz? And what you're going to find is that there's a couple of basic operations that a bunch of different routes use. And I would write a function to simply check if a user owns the quiz and so forth, have it throw an exception if they don't. And then, or, maybe whatever, it's up to you really. And then check for it in the server. So like I would call a function in the server to check about that permissioning. But there's lots of different ways you can do it. Tutors are pretty keyed into this. It's a positive change for the project that was introduced a couple terms ago. And usually once something's in for a couple terms and a bunch of tutors have had to mark it, and a lot of other tutors, ex-students, everyone kind of gets it. So go talk to your tutor about it. They should be super, super helpful on the topic. Anyway, I think that's it for me. There's no more questions left in the chat, so I'm going to wrap it up now. And yeah, hopefully that was interesting on the Auth front. Thank you. Thank you everyone for tuning in live. It's lovely to see you. I don't know if, let me just check. I can't remember if I have anything with you next week. Oh, my laptop's dead. Everything's dead. Just look it up. If it's the last time I'm talking to you, I want to say bye properly. No, oh yeah, is it? No, there's one more. Okay. I'll see you next week. We got one more lecture together, and then that's it for me and you for the term.